Bismillahirrahmanirrahim. Dear students, I am Dr. Salim Akhtar, Associate Professor of Chemistry. Now, this is lecture number 22 regarding the reaction mechanism chem4146. Now, in this reaction, we will discuss unimolecular theory of reaction rates in simple way. That is the Boolean theory of unimolecular reactions. We will discuss various theories proposed from time to time in this lecture. The unimolecular gas phase reactions are of first order under certain conditions, but they become of second order at low pressure. That is, unimolecular gas phase reactions are of first order under certain conditions, but they become of second order at low pressures. Boolean theory fails to explain unimolecular reactions. Boolean theory fails to explain the unimolecular reactions. Why this theory fails to explain the unimolecular reactions? In order to answer the above question, theories have been proposed from time to time. In order to answer the above question and to investigate the kinetics of such reactions, following theories have been proposed from time to time. Number one is the Perron's theory. This theory was put forward by Perron in 1919. Now, dear students, in 1919, Perron suggested that in unimolecular reactions, the molecules are activated by absorption of IR radiations emitted by the sides of the containing vessel. Now, dear students, in 1919, Perron suggested that in unimolecular reactions, the molecules are activated by absorption of IR radiations emitted by the sides of the containing vessel. But this view was found unsatisfactory and finally rejected. Failure of the theory. Failure number one, the experimental evidences could not be traced out in support of this theory. That is, this theory was not supported experimentally. Number two, Perron's suggestion was that the unimolecular reaction rate is independent of pressure, but in actual practice, it has been observed that the rate constant does not remain constant at very low pressure. Once again, dear students, Perron theory In 1919, parents suggested that in unimolecular reactions, the molecules are activated by absorption of IR radiations emitted by the sides of the containing vessel. But this view was found unsatisfactory and finally rejected. Failure of the theory. Experimental evidences could not be traced out in support of this theory. Number two, Perrin's suggestion was that the unimolecular reaction rate is independent of pressure. But in actual practice, it has been observed that the rate constant does not remain constant at very low pressure. Now, dear students, the second theory given was by Henschel-Wood, and this theory was called Henschel-Wood theory. Now, dear students, it is also necessary to consider here the way the activation energy is required in the unimolecular reaction. In this, it is also necessary to consider here the way the activation energy is acquired in the unimolecular reactions at low pressure. At low pressure, the rate of formation of activated molecules is equal to the rate of decomposition. That is, at low pressure, the rate of formation of activated molecules is equal to the rate of decomposition. That is, K1 is equal to Z e raised to the power minus E star over RT as in simple Coulomb theory. Here K1 is the rate constant, Z is the Coulomb frequency factor, E star is the energy of activation, R is usual gas constant, T is the temperature. The experimental results at low pressure, however, showed that decomposition rate is often much higher than the rate at which the activated molecules are produced by Coulomb. That is, experimental results at low pressure, however, showed that decomposition rate is often much higher than the rate at which the activated molecules are produced by Coulomb. For example, number 1, the decomposition of acetone at 835 Kelvin and 1 atmospheric pressure. The rate of activation of molecules per cc is 5.4 into 10 raised to the power 10, whereas number of molecules decomposing per cc is 1.3 into 10 raised to the power 16, that is million times greater. Now, dear students, once again, it is also necessary to consider here the way the activation energy is acquired in the unimolecular reactions. At low pressure, the rate of formation of activated molecules is equal to the rate of decomposition. That is, K1 is equal to Z e raised to the power minus E star over RT as in simple Boolean theory. The experimental results at low pressure, however, showed that the decomposition rate is often much higher than the rate at which the activated molecules are produced by cooling. For example number 1, the decomposition of acetone at 835 Kelvin and 1 atmospheric pressure, the rate of activation of molecule per cc is 5.4 raised to the power 10, whereas number of molecules decomposing per cc is 1.3 into 10 raised to the power 16 million times greater. So, in the second example, in the isomerization of cyclopropane, in the isomerization of cyclopropane, the decomposition rate is 10 to the power 5 times higher than the rate of formation of activated molecules calculated from the simple theory. Again, in the isomerization of cyclopropane, the decomposition rate is 10 raised to the power 5 times higher than the rate of formation of activated molecules calculated from simple Boolean theory. Now, dear students, it was pointed out that the expression K1 is equal to Z e raised to the power minus E star over RT is applicable to only those molecules having only two translational degree of freedom. It was pointed out that the expression K1 is equal to Z e raised to the power minus E star over RT is applicable to only those molecules having only two translational degree of freedom. Dear students, it is now believed that in unimolecular processes, the activation energy is acquired not only from the translational but also from other degree of freedom such as vibrational, rotational, etc. In other words, a number of degree of freedom are utilized in supplying the activation energy. Now, dear students, it was pointed out that the expression K1 is equal to Z e raised to the power minus E star over RT is applicable to only those molecules having only two translational degree of freedom. It is now believed that in unimolecular processes, the activation energy is acquired not only from the translational but also from other degree of freedom, such as vibrational, rotational, etc. In other words, a number of degree of freedom are utilized in applying the activation energy. Now there are also some limitations to this theory, that is limitation of the theory. Number one, it does not in general account satisfactory for the observed variation of velocity constant with pressure. That is, it does not in general account satisfactory for the observed variation of the velocity constant with pressure. Limitation number two, this theory assumes the unrealistic assumption that the activation energy per molecule is distributed among all or many of vibration modes of molecule. Number two is this theory assumes the unrealistic assumption that the activation energy per molecule is distributed among all or many of vibrational modes of molecule. Number three is it assumes that excess of energy in vibrational modes above the activation energy does not increase the probability of reaction. That is, number three, it assumes that excess of energy in vibrational modes above the activation energy does not increase the probability of reaction. Once again, limitation of the theory. Number one, it does not in general account satisfactory for the observed variation of velocity constant with pressure. Number two, this theory assumes the unrealistic assumption that the activation energy per molecule is distributed among all or many of vibrational modes of molecules. Number three, it assumes that the excess of energy in vibrational modes above the activation energy does not increase the probability of reaction. Now, dear students, the next theory, number three, Kazal-Rice-Ramsperger theory, to overcome the difficulties of previous theories of unimolecular reactions. They proposed that number one, a molecule must possess at least the activation energy in a single vibrational bond as a necessary condition for decomposition. Assumption number two, the excess energy in the molecule above the activation energy enhances the probability of reaction by increasing the chance that the bond in question will possess the necessary threshold energy increment. Number three, On the basis of the above assumptions, these workers gave the following expression. Now again, the Kazan-Rice Ram's object theory to overcome the difficulties of previous theories of unimolecular reactions. They propose that number one, a molecule must possess at least the activation energy in a single vibrational mode as a necessary condition for decomposition. Uh, Number three, assumption number two, three, the excess energy in the molecule above the activation energy enhances the probability of reaction by increasing the chance that the bond in question will possess the necessary threshold energy increment. Now, dear students, on the basis of the above assumptions, these workers gave the following expression. A plus A, that is two molecules of A, they will collide and form A and A star with a rate constant K1 in the forward reaction and K2 in the backward reaction. The activated molecule A star then converted into product with a rate constant K3. K3 is equal to K star into E minus E star over E raised to the power S minus 1, where K star, that is the rate constant corresponding to the completely free passage of the system through the activated state, uh, when E is very larger than E star, then from the above equation K3 is equal to K star. K3, that is equal to K star, which means that the energized molecules pass at once in the activated state. That is, K3 is equal to K star, which means that the energized molecules pass at once in the activated state. Otherwise, a longer period of time is involved, the time decreasing with increase in the value of E. Dear students, this theory was criticized by Slater mainly on the grounds that the proposed model assumes that the intermolecular transfer of energy between vibrational degree of freedom is very rapid compared to that of reaction. That is, this theory was criticized by Slater mainly on the grounds that the proposed model assumes that the intermolecular transfer of energy between vibrational degrees of freedom is very rapid compared to that of reaction. Slater assumes Slater assumes that the rate of intermolecular vibration energy transfer is very slow. Now, dear students, uh, next is the Lindemann's mechanism or Lindemann's theory. Now, this theory is very accurate in considering the reactions of unimolecular reactions. Uh, this theory was put forward by Lindemann. The main postulates are the unimolecular process. Only in the unimolecular process, only one reacting molecule takes part in the reaction. That is, in the unimolecular process, only one reacting molecule takes part in the reaction. It is known fact that collisions between molecules must occur to attain the energy for the reaction. It is known fact that the collision between molecules must occur to attain the energy for reaction. In this, in this, if this is the case, then unimolecular reactions should follow the second order kinetics. But in fact, it is the fact is but the fact is that all unimolecular reactions are first order reactions except in gas phase at low pressure. Dear students, in 1922, Lindemann proposed a hypothesis which offers a satisfactory solution to the problem. The assumptions of this hypothesis are given below. Number one, reactant molecules acquire energy of activation by collision with one another. That is, the first assumption is the reactant molecules acquire energy of activation EA by collision with one another. The second assumption is that the activator molecules do not decompose immediately but move around in the activated form for a while. Thus, there is time lag between activation and deactivation. That is, the activated molecules do not decompose immediately but move around in activated form for a while. Thus, there is a time lag between activation and deactivation. Next is the deactivation of molecule takes place as a result of collision with less energetic molecules. That is, the deactivation of molecule, the deactivation of molecule takes place as a result of collision with less energetic molecules. Now, dear students, you have already discussed in previous lectures the Lindemann theory mechanism in detail, though we will not go into detail at this moment. Thank you.